Hi Charlotte. So here is our little video that I promised you for this weekend. Instead of doing a question from each of the self-checks that I promised you, what I'm going to do is do a self-check or a question from each of the sections on the quiz. That way you can write this down on your quiz. I'm not going to count it against you that I did it, but that way you don't have to keep on flipping through a bunch of papers. And you can just go through this one quiz. So, and I'm going to do them for each section. I'm only going to do the 3 sections that I talked about. So like I'm going to do one question from 13 through 15, one question from 16 through 18, and then one question from 19 and 20. And so you should be able to do the remaining questions, but obviously we can talk about it the next time I see you if it doesn't work out. So I'm going to start with the solve each system of linear equations using Gaussian or Gauss-Jordan elimination. And I'm going to do number, I'll do number 14. So 14 looks like this. In fact, I'm going to just start with the matrix. And the matrix, we have x minus 2z equals -5 in the first blank, in the first line, so it'll be 1 for the x, 0 for the y because there's no y in that first equation, and then -2 for the z. Then we're going to draw that line. There's like a line that separates. It's kind of like where the equal sign would be. And then -5. So that represents our first equation. And then we have second equation would be -2, -5, 1, and 22. Then the last equation would be 2, 5, 3, and -18. Okay, so now what we're going to do, the goal here is to get this to look like it has ones down the diagonal. So like this one's a 1, this one's a 1, and this one's a 1. And then everywhere else is zeros. So the way that we're going to do that is with this Gauss-Jordan elimination thing that we've talked about. And so obviously the top left number is already 1, so we're good there. Once you get that number to be 1, so once this guy is a 1, what I'm going to do is now go down the rest of the column, so the -2 and the 2, and I'm going to get those to go away. The way I'm going to do that is by saying, let's see, 2 times row 1 plus row 2. So what that does is all I'm going to do is change the row 2. The row 1 stays exactly the same and the row 3 stays exactly the same. So I'm going to just rewrite the row 1 and row 3 really fast so that I remember that they stay the same. Let's see. Okay. And then I'm changing row 2. And so the way I'm going to change row 2 is I'm going to multiply 2 times row 1, which gives me so 2 times row 1 would give me 1 times 2 is 2, 0 times 2 is 0, -2 times 2 gives me -4, -5 times 2 gives me -10. And it looks like I'm changing row 1, but I'm not. I just wrote those like little numbers just so that I can remember what they are. Then I'm going to add that to row 2, like this row 2. So now I'm going to do 2, like this 2, plus this -2, which gives me 0. Now I'm going to do the next column, which would give me 0 plus -5, which would give me -5. Then I'd have -4 plus 1, which would give me -3. And then I'd have -10 plus 22, which would give me 12. Okay, cool. And so then, not that you have to do this, but really we don't need these little numbers up here anymore, and so I can just erase them. Okay, so now the next step is to get rid of this 2. And it's going to be super similar to what we just did. We're going to do, let's say, row -2, row 1, plus row 3. And once again, I'm only changing row 3 this time. So I'm going to rewrite row 1 and row 2. And then -5, 12, and then we're going to just change row 3. So to change row 3, the first thing I'm going to do is multiply -2, the row 1 by -2, which would give me -2, 0, 4, because -2 times -2 gives me a +4, and then +10. All right, now we're going to add that to our row 3, which is this guy right here. So it'd be -2 plus 2, which gives me 0. Then I'd have 0 plus 5, which gives me 5. Then I'd have I would have 4 because of this 4 right here, plus 3, which gives me 7. Then I'd have 10 plus -18, which gives me -8. Okay, cool. So now the first column is 1, 0, 0, which is exactly what we want. So the next column, what we're going to do is the first thing, no matter what happens, you always want to change the thing that you want to be a 1 first. And so we want this -5 to be a 1. The way that we're going to change that to be 1 is by dividing, or I'm sorry, I should say multiplying everything in the second row by -1/5. So I'm going to say -1/5 times row 2. Now, when I multiply by -1/5, you can just plug these into a calculator, but when I multiply by -1/5, that should change that -5 to 1. So notice we're only changing row 2 in here, so I'm going to rewrite row 1 and row 3 so that we remember we're not going to change them. Oh, okay, then 0, 5, 7, -8. Okay, now we're going to multiply everything in that second row by -1/5. Well, 0 times -1/5 is still 0. -5 times -1/5 is 1, which is what we wanted. -3 times -1/5 gives me 3/5. And then 12 times -1/5 gives me -12/5. Okay, great. We're getting closer, I promise. So now what we're going to do is our second row, sorry, I'm running into other chunks. Our second row our second column is almost ready, except for we need to change this 5 right here to be a 0. So the way that we're going to do that is we're going to say -5 times row 2 plus row 3. And we're only changing row 3. So I'm going to rewrite rows 1 and 2. Sorry, I forgot to draw that line. Okay, and then -5 times row 2, I'm going to just write them up right here. So -5 times 0 would give me 0. -5 times 1 would give me -5. 3/5 times -5 would give me -3. And then -12/5 times -5 would give me +12. All right, now we're going to add those numbers to the third row. So 0 plus 0 gives me 0. -5 plus 5 gives me 0, which is what we wanted. -3 plus 7 gives me 4. And then 12 plus -8 also gives me 4. All right. And then once again, I haven't really said this, but like obviously we had to multiply, and so that's why we were drawing those little numbers, but now we can erase them if we want. Okay, so we're really close. Our first column is perfect. Our second column is perfect. Now we've got to figure out our third column. And so our third column, the first thing you want to do is get the thing that you want to be a 1 to be 1. And we want this 4 to be a 1. This 4, sorry. So the way I'm going to do that is multiply the third row by 1/4. I'm going to say 1/4 row 3. We're changing row 3, so I'm going to just rewrite row 1 and row 2 again. So 1, 0, -2, 0, 1, 3/5, 0. Oh, sorry, whoa, not writing that yet. -5, -12/5. Now I'm going to do 1/4 times the third row. So 0 times 1/4 is 0. 0 times 1/4 is also 0. And then 4 times 1/4 gives me 1. 4 times 1/4 gives me 1. Okay, beautiful. So now I'm actually going to tell you kind of like a cheater version of this. Once you get through that and you have ones down the diagonal, so let me just show you with a highlighter. So once you have ones down the diagonal right there, and then zeros all the way around here, you can actually solve this. Like this can be, you're done with your matrix, because what that tells you is that now I can write this bottom row tells me, like these things tells me that z is equal to 1. The reason why I know z is equal to 1 is because that third, the bottom row represents z, and this number 1 right there represents z, and then our answer is that one. So z is equal to 1. Now, for the second row says y, because that's this number 1 right here is your y, plus 3/5 z is equal to negative 12/5. Then the third row says x, which is this one right here, minus 2z is equal to negative 5. The good news here is you still have to solve a little bit, but because I already know that z is equal to 1, then this equation would be y plus 3/5 times 1, which is just 3/5, is equal to negative 12/5. And I can solve that really easy because all I have to do is subtract 3/5. When I subtract 3/5, I end up with y is equal to negative 15 over 5, which is equal to negative 3. So y is equal to negative 3. I'm going to write that down right here. And then the top equation, once again, we already know z is equal to 1, so I'm going to replace the z with 1, which would give me x minus 2, because 2 times 1 is 2, equals negative 5. I solve that for x by adding by the 2, and I end up with x is equal to negative 3. I'm going to write it down here. And these are my final answers. So that's how we use Gauss-Jordan elimination. Okay, so that was a kind of a long process, but you should be able to do that for number 15. And then 13 is a 2x2, which you're doing the exact same thing. It's just way smaller. You don't have to deal with as many. Okay, now we've talked about Cramer's rule a little bit, but I'm going to talk about it a little bit more. Let me just grab some space over here. Okay, so for Cramer's rule, let's do number 17. So the first thing I'm going to do is just draw my matrix first. So let me write down that it's number 17. Okay, so our matrix would be 6, 0, negative 4, and 22. And then it would be 0, 2, 1, 6, and then 5, 0, 4, negative 11. All right, so here's what we're going to do. We're going to write 4 different matrices, four different matrices. So the first matrix is just the original, like on the left side. And I'm going to call that matrix just regular old D. So matrix D is 6, 0, 5, 0, 2, 0, negative 4, 1, 4. All right, and then we're going to write a couple more. The next matrix is going to be D sub x, and D sub x is the same equation, or the same matrix that you just wrote, but now it's, we're going to replace that first column with our answers. So, instead of writing 6, 0, 5 in the first column, I'm going to write 22, 6, negative 11 in that first column, and then still keep everything else the same. So 0, 2, 0, negative 4, 1, 4. Then I'm going to write D sub y, and D sub y, I go back to my original matrix, and I keep the first column the same and the third column the same, but the second column gets replaced by your answers. So it'll be 6, 0, 5, and then instead of saying 0, 2, 0, I'm going to say 22, 6, negative 11, and then negative 4, 1, 4. And then my last matrix is D sub z, which I hope you would have guessed. First column, second column are the same, but the last column gets changed out by the answers. So it'd be 6, 0, 5, 0, 2, 0, and then 22, 6, negative 11. All right, so here are our 4 matrices based on the original equations. And now what we want to do is find the determinants of each of these. So the determinants of each of these, you should have that big formula written down. If not, let me hurry and write it down for you. And I'm going to write it down, let's see, up here. So a determinant of a 3 by 3 matrix is A, times EI minus H. Oh my gosh, I just said H and then I wrote F. Let me try that again. HF minus B times DIFG minus FG plus C times DH minus EG. All right, and then obviously there's just a bunch of letters right there, but remember we're talking about a 3x3 matrix, which would be like A, B, C, D, E, F, G, H, I. Okay, so now when we want to find the determinant of this first matrix, this D, it would be 6 times 2 times 4 minus 1 times 0 minus 0 times 4 minus 1 times 5 plus negative 4 times 0 times 2 minus 0 times 5. Okay. And then to solve that, you can just plug that into a calculator. I'm going to tell you that one cancels out because it's just zeros. That one also cancels out just because it's zeros. You could plug it into a calculator and it would work out, but you're going to end up with just the first part, 6 times 2 times 4, so 8, it's 48. Okay, so this is just 48. All right, now let's do it again for the second matrix. So for the second matrix, we're going to have 22 times 2 times 4 minus 1 times 0 minus 0 times 6 times 4 minus 1 times negative 11 plus negative 4 times 6 times 0 minus 2 times negative 11. All right, and then let's see. If that one's going to cancel out because it's multiplied by 0. Then I'm going to have negative 22. Okay, that is a calculator one for sure because my brain doesn't work that fast. So we're going to do 22 times 8 minus 4 times 22. Okay, that gives me 88. All right, and then that doesn't make sense. Okay, 1 minute. I'm going to plug that into my calculator one more time. That doesn't make sense. One sec. Let's see. So 6, 2 times 4 minus 1 times 0, 0, 0 times 4, negative 4, 2 times 4. Oh, I screwed this front one up. Okay, I screwed up the top one. Let me erase it really fast. I just screwed up the very last part. So for that C part, it'll be plus negative 4, 0 times 0 minus 2 times 5. Which doesn't cancel out, so we can't just cross it off. So then I'd have 48 minus 4 times negative 10, which also gives me 88. Okay, this is going to work out now. Sorry that I screwed that one up. Okay, now let's go to the Y one. When we plug that into the formula, we're going to have 6 times 4 minus 1 times negative 11 minus 22 times 0 times 4 minus 1 times 5 plus negative 4 times 0 times negative 11 minus 6 times 5. Okay, when we plug that in, what's going to happen? Let's see. So 6, 24 plus 11 is 22. I get... Okay, that gives me 440. All right, and then the last one. So now we have 6 times 2 times negative 11 minus 6 times 0 plus 0 times negative 11 minus 6 times 5. Sorry, that should be a minus, but it won't really matter because it's a 0. Plus 22 times 0 minus 2 times 5. All right. When we plug that into a calculator, those zeros cancel out, and we're going to end up with 6. Negative 352. Okay, so obviously that took a little bit of time and I screwed something up, but these numbers should work out now. So now what we're going to do is, oh, sorry, that got a little bit too. Okay, in order to find x is equal to dx over d. Y is equal to dy over d, and z is equal to dz over d. Now, good news, we already have those numbers. So dx over d would be 88 over 88, which is equal to 1. So my x is 1. dy over d would give me 440 over 88, which is equal to 5. And then dz over d would give me negative 352 over 88, which gives me negative 4. And hooray, those are my answers. So x is 1, y is 5, and z is negative 4. Okay, once again, that did take some time, but it wasn't like terrible. Okay, let's go through now one of the last ones. And in this case, I'm going to do, so there's only a 2x2 and then a 3x3. I'm going to do the 2x2 because I want to see if you can do the 3x3. But these ones are the inverse matrix method. So first of all, what I'm going to do is write down 2 matrices. The first matrix I'm going to call matrix A, and this matrix is like the question part of it. So it'll be negative 3, negative 2, 4, and 2. Sorry, this is for number 19 too, if I didn't already say that. And then we're going to have a matrix B, and the matrix B is the answer matrix, and so this will be negative 7 and 6. All right, so in order to use the inverse matrix method, what it would be is, like, what we want to do is do the inverse of A, which is A to the power of negative 1, times matrix B. And that should give us our answers. So the first thing we have to do is find the inverse of matrix A. If you remember, to find the inverse of matrix A, it's 1 over the determinant of A times, let's see, the formula would be D, A, negative B, negative C. And so for our question, we have 1 over, and remember, for a 2x2, the determinant is AD minus BC, right? So for our specific question, it'll be 1 over negative 3 times 2 minus negative 2 times 4 for the determinant. And then in our matrix, we'll have 2 and negative 3, positive 2 and negative 4. All right, so let's just simplify that a little bit. We'd have 1 over, let's see, it gets negative 6 plus 8. So it's 1 over 2 times that. 2, negative 4, negative 3. And I'm going to actually multiply that 1/2 through, which would give me 1, 1, negative 2, and negative 1.5. So that's my inverse of matrix A. Great. So now what we're going to do is actually multiply it by matrix B. So I'm going to have 1, 1, negative 2, negative 1.5 times the matrix B, which was our answer matrix, which is negative 7 and 6. All right, so when we multiply matrices, we do this row times this column, which would give us, okay, wait, pause. Let's start over. So this is a 2 by 2 matrix. This is a 2 by 1 matrix. In order for them to multiply, be able to multiply, these two numbers have to be the same, which they are, so that's great. And our answer would be the outside two numbers. So our answer is going to be a 2 by 1 matrix. And so the first number is going to be the first row times the first column, which would give me 1 times -7 plus 1 times 6. And then the second answer will be the bottom row times that same column. So -2 times -7 plus -1.5 times 6, which when we simplify that should give me -1 and then let's see, 14 and 5. So that means, what that tells me is that x is equal to -1 and y is equal to 5. And those are my two answers. All right, so obviously this was a crazy long video. Do what you can, but also understand that we will talk about it and do whatever we need to do later this week together, okay? Good luck.